work at a higher level, if you want to create digital twins and interfacing software to hardware, etc. So basically, these are the two main sections, and we have solutions for both these sections. If you're talking about robotics at a cell level, yes. And even at a manufacturing automation level, at a system level, yes, we have solutions for that also. Now, coming to RoboDK, uh, in brief, RoboDK is one of its a unique type of software which has multiple brands and models of robots. So it is an industrial robo software in which you have 2, 3, 4, 5, 6, 7 axis robots. That, but even the the series of the robots, for example, ABB, let's say you want IRB 120 series of Hanuk something else, or let's say you want Yaskav Motorman series, all these are available. So they're like 400-500 different types of robots themselves. You'll also get SCARA robots, Delta overhead robots, all these are available in one single environment. Besides that, we have more than 200 plus types of grippers, 2 and 3 finger grippers, vacuum grippers. Then even these are from industrial manufacturers. So if you see the grippers available in the market today are from companies like Robotech, Shang, follow project using a pencil. You want to draw something, you want to curve a trace on a 3D object, you want to do what do you say, arc welding, you want to do spot welding. So these type of tools are also available. Also, we have a single environment teach pendant. So in this, you have the entire what do you say, access to all the joints. You can do Cartesian. You have access to the internal inverse kinematic parameters of each robo of every brand, and all these can be accessed. And then we have some very fancy commands like find target on surface, do this, do that, which makes robo programming very easy. Also, things like collision detection. Then in RoboDK, we have all the objects required to create a robotic cell. For example, if you want a work table, you want objects, you want maybe a type of a wise thing which will hold the object, pallets, trays, tables, grippers. And using all these, you can create your standalone robotic cell. Even things such as assembly of objects, material handling, palletizing options, drilling, milling, inspection, welding, etc. So these are all possible in RoboDK. Now, before we go to the next slide, there are certain things I also want to point out, because there are, I see quite a few senior people in this seminar today. And just to give you an insight, in the industrial robotics arena, okay, 1 minute. I did Jamshedpur. Okay. Now, in the industrial robotics arena, the most common industrial applications are things like arc welding, spot welding, material handling, machine tending, painting, picking, packing, palletizing, assembly, mechanical cutting, grinding, deburring, polishing, gluing, adhesive, and these type of industrial processes. And this is a large chunk of employability available in the market today. So if you look at job wise, the biggest section is here. And then, of course, there are non-industrial robots like what the humanoids and the hexapods, etc. But that's a very small market, and that's more into the development level. And unfortunately, I don't know, most of the colleges are concentrating on the non-industrial applications of robotics. Yes, it is important, but job-wise, the biggest chunk of jobs is in the industrial applications. Also, to give you an insight, for example, if you see the skill development of Karnataka, now in the last 6 months, they have upgraded around 100 ITI skill centers and put up infrastructure for industrial robotics and digital manufacturing. So they have gotten into robotics programming. They have got the hardware for robotic cells, etc. And these more than 100 have suddenly cropped up in the last 6 months in Karnataka as robotic and manufacturing automation courses they are running. So you have manufacturing and process control automation, and you have industrial robotics, digital manufacturing. Also, they are running courses such as Industrial Robotics 1, Industrial Robotics 2. So this is just to give you an insight as to what is happening. Okay. Then coming back to the actual robotics, the biggest market chunk today is worldwide and in India is Fanuc, ABB, Yaskawa, Kuka, Mitsubishi. These are holding the, what do you say, the entire demography of robotics in India and worldwide. And coming to what do these software provide? Okay, besides buying the actual robo, if you buy a robo from Kuka, directly they'll just give you a package robo, no gripper, no nothing else, and the Kuka programming software. So the robot programming language for Kuka is KRL, Kuka programming language, and the software they provide is Kuka Sim. Okay, so this is one environment totally by itself. So Kuka Sim is a software. So this is what Kuka Sim looks like. And the best part is that in RoboDK also we have the entire range of Kuka robots. So you don't have to learn different software independently for different bands of robo. Similarly, if you go to Fanuc, the Fanuc programming language is known as Karel. The software which comes with this is known as RoboGuide. There are quite a few installations of Fanuc all over India and using RoboGuide. This is again a proprietary language. Okay. All these are proprietary to the robo manufacturers. So this is what RoboGuide looks like. And yes, we have all the robos of Fanuc in RoboDK also. These are also available. Then coming to Mitsubishi, Mitsubishi has a language by the name of Melfa Basic 4.5. And the programming software for these robots is known as RT Toolbox. Even we have supplied this with our hardware. For example, CET Bhuneshwar, they are using our Mitsubishi robotic cell setup and RT Toolbox. So this is what it looks like. And we also have all the Mitsubishi range in RoboDK. Then again in ABB, we have programming language known as Rapid. And then the programming software is RoboStudio Suite. And yes, that is also available in RoboDK. Okay, Yaskawa again. Yaskawa has this Motorman range, and Motorman range is also available in RoboDK. So the point being that one single environment, you don't have to be confused about which software to buy, not buy. This covers almost the entire range. Also, another few things, if you notice, I don't know how many of you are already using industrial robotics software. If you see the screen, for example, this is Mitsubishi, you'll see these red, green, blue vector points. These are known as reference frames. So this type of robo programming is common to almost everyone. Okay, they are available in here, for example, in Mitsubishi, in RoboDK. If you see in ABB, again, these are there. So these are known as reference frames, and the entire crux of robo programming, let it be RoboDK or any other software, is a reference frame programming. This is the crux, what it uses. Okay. So this will be more clear once Kunal starts his working copy demonstration in the importance of these particular reference points. So that is that. Then also in terms of welding, RoboDK also has a huge list of ready-made robotic cells, which are like what do you say, ready-made robotic cells. Instead of buying hardware, we have equivalent software models of this, and they are for a lot of applications. Kunal will show you a few of these. So for example, for spot welding, okay, we have different types of brands, Fanuc, Kuka, Yaskawa, Motorman, these are there. And for example, Fanuc has no, for welding, they have something known as Fanuc ArcMate, specially made for welding applications. And then what are the tools used? And then what are the features required for welding applications? So for welding applications, for example, you see these white vector points here. These are the entry points and exit points. So the rover will come along this entry point, do a arc welding, and then exit from the other point. So these are features required for any simulation software, and these are very important. So if you see arc welding, it uses a curve follow sequence. If you're using spot welding, it is point-to-point entry and exit sequence. So this will be demonstrated by Kunal again in the working copy. So these are few pointers I wanted to point to you. Also, RoboDK, there is a list of post processors available. Okay. Now, for advanced users, maybe at MTech and above level, people who really want to experiment with, they have the hardware. So RoboDK has an entire list of post processors available. So if you see here, the entire list of post processors here. So like a CAM software, you do the CAM programming and then you want to send it to a particular maybe Fanuc OIMH series of a control panel, etc. So similarly in robotics also we have an entire list of post processors available. Also there are drivers available. This is for people who want to do direct operation of a hardware robot. So following list of drivers are also available in RoboDK. But this is like I told you for people who want to do advanced work in robotics. So this is also available. Okay. Then okay. Now one last small thing before we hand over to the working session is okay. Yeah. One is the curriculum of robotics. Okay. Now, like I told you before, there are two sections. One is a robotic cell and one is a robotic system level. Okay. So at cell level, you see whatever is marked in yellow, RoboDK is very, very comfortable in handling here. Whereas if you see the blue section, this is system level and this requires more advanced software. And IndiaSoft has another advanced software by the name of Visual Components. And we are having a similar webinar on the 17th. At what time? Okay. So on the 17th, we have another webinar, which is for the that today's area is robotic cell industrial level programming. Now, another thing in visual components, okay, visual components is also another software which you sell. This does the system level programming. Here you can build entire 3D factory automation sort of a system. So your computer integrated manufacturing, flexible manufacturing systems, your data throughput, but everything in 3D here. Okay. So you can actually create an entire system like this. So this is, for example, you can have ASRS, warehousing, conveyor belts, automated guided vehicles, and interfacing to multiple CNC machines, assembling of objects. We also have, I'll just get straight to the library. Yeah. If you see the library here, you have things like ASRS, conveyors, factory layouts, feeders, different types of machines, CNC machines, mobile robots also we have. And then we also have the output. So once you simulate the entire system, you can get things like cycle times of the robots, how much time was spent in one machine. You will get the entire data report also. So this is a different animal altogether, this particular software. And this is what visual components looks like. This is for system level. But this is not the agenda for today. I don't want to waste time on this. And before I hand the session, just one last thing is that we also, IndiaSoft also has a software for CNC programming, because we saw that in manufacturing automation, CNC part programming and simulation has come in almost every syllabus. So besides the system level of robotics programming, cell level, CNC part programming has come into the syllabus. So for that, we have special software. So anyone interested, you can get in touch with us. We have part programming software. Okay. So we have this. Not only that, you can see the simulation of this part program also. So we have something known as DigiCNC, which is a trademark software of IndiaSoft. And in this, you can work it in a dual screen mode. So on one monitor, you can have a touch screen where you can open up the control panels. So instead of investing so heavily in lakhs and lakhs of rupees in CNC machines, you just have to go into dual display mode. So on one side, you'll see the machine simulation, and on the other side, you can see the actual control panel of a CNC machine. Because in colleges, we know teachers are very scared to let students operate real CNC machines. So these are some of our installations in which there's a touch screen at the bottom and a 40-inch TV at the top. And you can actually see this, it's like a virtual CNC machine. So we have an entire solution for CNC part programming as well as a virtual CNC machine. Okay, so I'll be coming back for the custom gripper and custom robo at a later stage. Now I'll just hand over the session to Mr. Kunal. He'll take you through the working copy. Okay, thank you.
Am I audible? Hello? Hello?
Tell me, sir.
Kunal here, am I audible?
Yes, sir, audible.
Yes,
One
sir. So
second.
further session will be conducted by me. Present my screen.
Kunal,
Hello?
audible?
Yes, yes. Is my screen visible?
Yes, sir. Yes, yes.
Yes. So this is the working copy of RoboDK. This is the working environment. This is the interface of the software. So first of all, I'll start with the explanation of some particular icons. So these are all the icons here. This is icon to open or load file from your local library. Here you can see this is my local library. This icon is to open the robot library which is provided by the makers of the software, which is online library you can see here. These are various types of robots available. As explained prior, more than 500 to 700 robots and more than like 50 to 70 robot manufacturers are here. You can select the brand from here. Any brand which you need. Here from here, you can add filters. You can select type of the robot, like 5 degree of freedom, 6 degree of freedom, 7 degree of freedoms from here. As per your needs, here are the axes you need to select from 1 to 7. This is the reach, which is from 100 mm is the minimum and 20,000 mm is the maximum in this library. Here is the payload capacity of a robo. You can change it from here as per your need. This is the weight, and here is the repeatability of any robo. You can also select it filter. You can also apply filter for this repeatability function also. So these are the various types of robots in the online library. You also have grippers here. If you can see in the type and you say tools, see here these are various types of grippers in this library. Mechanism gripper, dispenser tools, various types of 2 finger grippers, closed finger grippers. As you can see here, there is a fan, spindle, various types of tools are also here available. So this is the icon for adding a new reference frame. I will explain you about the reference frame in the further session. This is to set targets. This further all these icons will be explained one by one as we go on in this session. So now if I take a particular robo, if I show you there, if I double click on this robo, here is the teach pendant of this particular robo. So as you can see, this is the axis movement you can see here. Like this, you can move this robo from this also. You can move it from this joystick also in the particular direction. You need to select the axis here, X, Y, and Z. If you can see here, it is moving using the joystick also. And if I say here home, the robot goes on its home position where it is at the home position. See here, if you can see, it is moving through its particular joint like this. If I click on the parameters here, these are the parameters of this robo, which are only available in the licensed copy of the RoboDK software. So here you can see the parameter of this particular robo, the speed, the joint speed, acceleration, joint acceleration, and here are the inverse kinematics windows of this particular robo, which is ABB CRB 15,000. As you can see here, these are the kinematic parameters and these are the robot parameters such as speed, joint speed, acceleration in this parameter section. You can also move this robo by using by selecting the frames. See, you can see here. You can also move this robo like this by selecting the particular frame. And if you right click on the robo and say move home, directly it goes to its home position. From this also you can operate it. So now moving further, I will show you doing some simple basic examples here. So first I will make a simple rectangle example. For that I will attach a like pencil tool. Here if you can see, the tool is directly
Hello,
attached.
hello,
Hello?
hello. Kindly
Yes,
share your screen. Kindly share your screen. We're not able to see the screen.
you are not able to see the screen.
Yeah,
Now,
only I could see the participants. That's all.
now, sir.
Now it is clear, it is visible, sir.
How
No,
it's okay.
screen is shared. Screen is shared.
Sir, I think the screen is shared.
Yes, 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 sir.
Okay,
Yes,
okay,
yes.
Okay, sir. So should I continue?
okay. Yeah,
Yes,
yeah.
yes, it's visible.
Yes, yes, sir. Okay, so as you can see here, the tool is directly attached to the robot. This is because of the reference frame. The reference frame of the gripper and the reference frame of this front end of the robot, it matches directly and the gripper is attached to the robot. So for doing a simple like experiment of making a rectangle, I need to first move this robo like a bit downwards, if you can say, like this. As you can see here, I will set the first target here. This is the icon for setting a target to a robo. Here I have set a first target. I will move it to another position, set another target, take it downwards, set new target, third target, and set it to fourth target here like this. Set target. So as you can see, the targets are set here for each in like other directions. So if I click here on this is the tree. You can see it on the left side. If you click on target 1, the robot will move there. Target 2, 3, and 4. So now I need to create a program of these 4 targets. So I will select all these targets and just you can see here, I will select all these target and right click on this and say here create a program. So this robot has created a program like for making a rectangle. If I run it on loop, if you can see here, the robot is moving in a rectangular direction like this. And as you can see here, a small like change is there in this rectangle. The 3 targets are in a linear movement and one movement is a joint movement here you can see. So I need to right click on this movement and say linear movement. Now if you can see, it has made a proper rectangle. So this is the basic experiment which I have shown you. So now moving further, I will show you Experiment for pick and placing of object. So here. So now I will take a robo first of all. I will mount this robo on a like table. For pick and place, I need to attach a two-finger gripper. I will take a open gripper here. These, as you can see here, as I told you prior, the reference frame are most important here. So the robot has totally taken itself the reference frame of the gripper, and the gripper is attached directly to the robot. So for pick and placing of object, I will need a object. So I will take a cube of 100 mm. So now moving this cube to its particular direction. So I will take this cube like under the uh, gripper. So if you can see here, if I double click on this robo, the teach pendant will open here. And now I need to move the position of the gripper. So the gripper is at the 180 degrees. So I will simply make here 90. See if you can see here the change occurred here. And now I will move this robot a little bit downwards in vertical direction for ease of its work. So now if you can see here, there is a function here available in this software. If I right click on the object and say here get with the robo and select the particular robo, the object, the gripper directly goes with the robo. So now if you can see here, the gripper has gone at its edge of this object. This is because of the reference frame. The reference frame of this object is at its, you can see here. I will move this a bit upside. Uh, if you can see here, the reference frame of this object is at the edge of its corner. So I need to bring it in the center. So it is simple. If I double click on this object, go to more options and move geometry. If I say, if you can see here, the reference frame is at that only position, but the object is moving according like as I need. So I will take it like this. Okay, so the reference frame is now at the center of the object. So now when I will move the robot to its home position. Take it 90 degree. Yeah, as you can see here. Now if I say get with the robo, you can see here the gripper has properly attached with the object. This is because of the movement of the reference frame which I did. I took the reference frame of the object to its center. So the reference frame of the gripper and the reference frame of the object has matched together, and the gripper is properly attached with the object. So now to pick an object, I just need to like I will move the gripper a bit above. I will set a target here. The set target. I will take it to the object. I will set another target. Now if you can see here, target 1 and target 2. So now to create a particular program for picking an object, I need to like say here create a program. So first program target 1 the joint move, target 2 I will make a linear move, and after that select a program. This is the icon for adding a simulation event for a program. So if I click here, add event and say attach object and to this robotic and say OK. And again click on program and say target one and say a linear move. If I double click on the program, if you can see the object is attached to the gripper. If I move the gripper, the object will move directly with the gripper only like this. So now this was the program for attaching an object to a gripper. So I will show you the same procedure there is for detaching this object. I will move this object to another position, place it on a table. You can see here. I will place this object on a table like this. And now I need to detach this object here. So I will first of all take this object a bit high like this. Set a target here, target 3. Set a target here, target 4. And again, target 3, create a program. Then select this program, set target 4 or linear move. Select this program and again I will add a simulation event here. Just we need to change here the attach object to detach object and to new station 1. Attach to the parent which is the new station 1 and say OK. So now and again select this program and say target 3 and give a linear movement. So now if I double click on program 2, you can see the object is released on the table. Now if you can move this gripper, the object is released on this table. So these were the two functions for picking an object and placing an object. So on the same basics, I have made a project for pick and place. Ready-made project it is there. I will show you. So if you can see here, this is the pick and place. This is the ready-made project for pick and place of an object. If you can see here, the object is picked from a particular position and placed on a particular position. And here I have added one more simulation event which is for replace the object, which you can add from the same icon here. It is for simulation, adding a simulation for replacing the object on its prior position. See if you can see here. This is the position 1. It picks the object from position 1, send it to position 2, and the object automatically replaces to its original position here. So this was the pick and place for object with open gripper. There is one more function which you can do it by mechanism gripper. So I will show you that also. If you can see here, this is the pick and place of a object with mechanism gripper. If you can see here, the gripper opens. Here the object is placed on its particular position. If I run this on loop, see if you can see here, the gripper closes. It takes to its position and the gripper is open. It closes. It picks the object. It places on its desired position, and the gripper is again opening. If you can see, there also replace of object function is applied. So the object automatically replaces on its prior position. So this is the program for pick and place with a mechanism gripper. So moving further, now I will show you some basic program for curve follow and a point follow project. As Praveen sir told you in the prior presentation, these point follow and curve follow projects are used in the welding simulations. For arc welding, arc welding is based on a curve follow project, and where it comes to a point follow or spot welding, point follow project is used. So first, going through curve follow project, I will show you. So for curve follow project, I will take a robot first of all. I will add a dispenser tool for a curve follow project. I will place this robo on the table. You can see here the tool is also attached to the robot. So for a curve follow project, I will take a prism. If you can see here, the prism is loaded on the table. So for ease of work, I will move it to its desired position like this. So now for this curve follow project, I will move first of all this robot gripper. This. So to curve follow project, there are some simple steps. The software has given you like direct options for the curve follow project. If you go in this utility section, you can see your curve follow project. There is a direct option for curve follow project. You just need to select this. This window will open. Here you need to say select curve. And once you select this curve, if you can see here, you just need to keep in mind this white points. So like this, you need to select one curve. Here you will select some another curve. And if you can see, if you say done here and you say update and say simulate, if you can see here, the robot is moving automatically through the selected curve. But I will go down the simulation a bit. Now, if you can see here, the robot is moving to the selected path. If you can see here, and these vectors are important. So if these vectors were not there in upward direction, if it will be in some other direction, the position of this dispenser tool will be in that direction. So the direction of this tool is depend on the direction of your vectors when you select. If you can see here, it is moving according to the selected curve. So this we have selected two curves only. I will show you. I have made a project for 4 curves all total. You can see a curve follow project. If I run this, now if you can see here, see these vector points. Now for your understanding, I have selected in this project this vector point. One vector point is selected in a bit slant way. So if you can see here, these vectors are in a straight direction, and here you can see there is a slant direction. So the dispenser tool moves according to the direction of the vector. If you can see here, the robot moves according to the vector. So this was the basic project for curve follow project. This curve follow project is used in arc welding. So you just need to select the curve which you need to weld and simulate the program. So moving further to point follow project. For point follow project, I will take robo, mount this on a table. Again, attach a simple dispenser tool. Take a prism as object. Moving this object to its position. So now if you see here, for doing a point follow project, there are 2 to 3 steps. So first of all, for doing a point follow project, we need to select a curve on which you need to select points. So for that we need to go in tools. We need to see here create curves, and here we need to select a particular curve. So I will select this curve, and I will say here right click on this curve and say here, just a minute. I will say done here. I will right click on this curve, say split curves, and set point spacing. So I will set this point spacing according to our need. I will set it at 30. So if you can see here, the point spaces are set at 30. So I need to again right click on here and say extract curve points. So if you can see here, I have extracted all curve points, and the points are, if you can see here, the points are extracted on this curve. So again, I will now go to utilities and say here point follow project and say select points. So now if you can see here, if I select one point, so I need to select this each and every point here. And 10. So see if you can see here, I have selected each and every point, and if I say done, I will say here update and say simulate this program. If you can see here, the robot is moving on these selected points. I will show you this view. As you can see here, the robot is moving on the selected points, on particular selected points.
Excuse me, sir. Sorry for the interruption.
Sorry, sir.
I
Please.
think, can I ask a question?
Yes, sir, please.
Sir, why it is required by point? If it is a
Sir,
straight
this,
surface, it is okay. Suppose if there is a curved surface or any kind of the regular surface,
yes,
then will it work the same point by point path?
yes, sir. If it is any on curve surface, you need to select that curve as a sir. As first, I selected this curve. So this, as it is the plane curve, so if it is a like any other shape also, you can select that particular curve and say extract points on that curve.
Is it equally distributed or just randomly you taken
The,
this?
no, sir, you can distribute it on your need. Like if I this I have set this point at 30, so it is equally distributed on a point of 30 here, sir, 30 mm. So the
It is
distance
mandatory
between.
to distribute equally or in any kind of ununiform length also it is accepted?
No, sir, it distributes equally, or you can set it on your position also. If you can right click here and say split curve, here are many options, sir. If you can see here,
Okay.
split here. If you click on a particular point and say split here, it will split on that position also. Yeah, I have did set point spacing, so I have set a particular point spacing. Here you can split it in half. You can split this curve in corners and split only the ends also, sir.
Now here I need, for example, from one point to the fifth point, I need a straight. Then
Okay.
from 6 point onwards till the 10 point, I need a curved. Can you do it in
Okay.
one simulation?
Yes, sir, we can do it.
Till up to first
You
to
need
fifth,
to
it is
you
straight.
need to select the particular point and say split here. See, sir,
Okay.
if you say split curve and so say here split here, the curve will split at that point where you have selected.
Yes, exactly.
Yes, sir.
Okay.
So this is the point follow project. So I will show you one ready-made project I have done on both the sides of the object. Here I have done done this project on both the sides. So it on this side I have not selected any curve. So here the robot moves plane. If you can see, I will slow down some simulation speed and show you from the first. So as you can see here, the point spacing between these two is a bit low. I have taken here 20 mm of point spacing. You can see here. This project is a basic project for spot welding. You can see the welding done on a particular another in on which spot we need. You can select that spot and say split here. So point follow is used for spot welding, and for arc welding we have seen prior curve follow project. So moving further, I will show you now some station for assembly. So this is based on a pick and place only. So first of all, if I take a particular robo, just a minute. So here if I have shown you first of all this I will take one more cube here. So for assembly, like I have told you prior, this is based on simple like pick and place mechanism only. So just we need to do is first of all I will change the I will take the reference frame of this object to its center. So now when I pick this object, particular object, if I say if I pick this object, here I'll set a target another. Get with the robo. Set target number 2. Create a program here. Program to target linear move. Select this program. Add this attach object here. And bring it back to target 1. Linear move. If I pick this object and I need to place this object now not on this table but on this cube, I need to assemble this both the cubes. So I will just take this on its particular direction where I need to assemble it. You can see here. I will keep this a bit slant so it will be easy to see like this. So now if I see, if you can see here, I have placed this object both on this each other, and now if I move this robo a bit backside like here and create a target here. bring it again here, create another target. So if I create a program with here, target 3, select target 4 and create a linear move. And now I will add a simulation event for program 2, say a detach object. And here you can see attach to parent. I will click here and say the another cube. So I will select the cube here. Just a minute. I'll need to change the name of this cube. Cube 1. Okay. So it will be easy for us to understand. So now if I click here like this modify and say detach object and say here, see if you can see here cube 1. If I say attach to parent cube 1 and say OK, again select program to target 3 and a linear move. So now if you can see here, if I double click on this program, see if you can see here the object is attached to this cube. So now if I move this downside cube, it will not move single, it will move as an assembly. You can see here. And above also if I move, it will move as an assembly because these both of the cube objects are attached and it is a now it is an assembly. So this is the basic pick and place project only, but you can modify it to a assembly also. So I will show you. I have made an assembly project here, ready-made assembly project, basic assembly. So here, if you can see, if I do a pick program, the robot comes, picks the object. If I say place, it places the object on this parent, and if I say assembly, it will select this assembly and move it. See if you can see, it selects this assembly, and now if you can see, the assembly is moving totally as a particular as a single object. If you can see here. Now here also I have attached uh, simulation event for replace objects. See if you can see here, I replace this object, it goes to its particular position. Again, if you can see here, pick the object, place it and make an assembly. It attaches to this parent object and it moves as the assembly, if you can see here. It moves as separate assembly. Again, if I say replace object, it goes on its particular position. So these are some of our basic projects. So now I will show you the some of the ready stations which are available in this software. As I shown you the first only online library for separate robots and grippers. So here beside robots there is a online library for stations. Here are some of the ready-made stations if you can see here. This is the ready-made stations. These are all ready-made stations. For various functions you can see here. So this is for curve following. Now this is for dispensing. This is for assembly line. If you can see here. These are all the ready-made stations. One I will open and show you. Just a minute. This is the ready-made station for curve following. If you can see here, I've opened this. It will take time. It is loading. Just a minute. See now, if you can see here, this is the curve following project, but on a different path. Wait a minute. This one. I will show you another ready-made station. Uh, See, like here, there are many other also stations. These all are on this curve follow project only. If you can see a curve follow dispensing, there are various projects. You can just select it and say simulate. It will show you the like particular design program. Here you can see, as you can see, this is for inspection. This is for machining. You can see here. There are various types of projects available here. This one is for pick and place, like you can say material handling. If you can see here. This is on the same pick and place basis only, but it has used some other gripper. This is a suction gripper which has been used here, and the objects are the various like 5 balls, and it is placing it on a particular like desired position. You can see here it is using a suction tool. So these are all the ready-made stations available in the library, online library of this software. You can see here. Here. So this is our working copy of RoboDK software. So any questions till now? Hello, am I audible?
Yes, Kunal, you are audible.
Yes, sir. So now I will further hand over this session. Yes. Okay, so now further I will hand over this session to our sir. For
Just a minute, sir. No, just a
yes,
minute,
sir.
sir.
Yes, sir.
Till now, whatever you shown is only on the plane surface, no, sir. Do
Okay.
you have any kind of the same existing software which can operate like a chamfered hole or countersunk hole or the surface kind of a thing, texture kind of a thing, embossing kind of a thing?
Embossing and
Texture or any kind of the hatchbacking or countersunk hole.
oh yes, sir. Yes, sir. It is also available in this software also, sir. If you can see, I showed you the ready-made stations here.
And
So in
here
this
one more
ready-made,
thing, one more question I wanted to ask you. And you have
yes,
selected for some program you selected ABB, some program you selected FANUC, something else. Is it
yes,
mandatory
sir.
to select particular program ABB, particular program FANUC,
No,
or for
no, sir.
all thing it?
All robots are you can use all robots for all programs.
It's not something else like only for particular kind of
No,
thing. This
no,
kind
sir,
of
no, sir.
robot.
It is not necessary that you can use this robot only for this program. You can use
Mhm.
any robot for any program.
Okay.
Yes, sir.
And here I think shown the Kuka and all these things. I think nowhere you use no. Only used only FANUC and ABB something else. That's what I.
No, no, sir, not. I have not think like that, sir. Only
Yeah.
you can use any robot, sir.
Okay.
Yes,
I
sir.
think for all robots, commands will be same and commands will be different.
No, sir. Commands are
Parameters
same only.
same only.
The interface is same. Only the robots will change, sir. Ji.
The physical skeleton will change. That's it.
Yes, sir. Physical skeleton will change.
Programming will remain same there itself.
Sir, program we need to set.
That's all. And it will
Yes, sir.
change for the each the
No, no,
manufacturer
no,
scenario.
no, sir. The interface is same. The icons
No,
are
no,
same.
no.
You will,
Like Kunal, what he's asking is,
yes.
see, program is generated at the end, correct? So
Huh.
today you're using IRB 120. Tomorrow you want to change it to something else.
That's
And
right.
Yes.
then at that point, see the interface of Cartesian joint programming, etc., is the same, whichever robo
Yes.
you use.
Yes.
Every robo will have its own degrees of limitations.
Yes.
It may do a singularity lock somewhere. You have to open
Yes,
that up.
yes.
The interface is the same, and depending on which robo you choose, there will be changes in the program which gets generated.
Programming.
Yes, the parameters of the robo will change, sir.
That's what, because basically, then what parameter will define the selection of robot?
Sir, now for pick and place, you can select any 6-axis robo.
You can even
But
choose
minimum.
the envelope. There's something known as the envelope command.
Yes.
That's what, sir, because as per the syllabus, I think he has mentioned only some simulation kind of a thing. Generally for the pick and place of a thing and other scenario, which they keep in consultation, and some of the things they have altered and some of the things they have changed, even with reference to the universities also. That's what I wanted to know, because basically the whatever the things programming software which is there in our one university may not be similar to the other university. Slightly there is change.
Okay. So what university are you?
So we belongs to Vishweshwara Technological University in Karnataka.
Okay, Karnataka. Okay.
Karnataka. That's what.
So we'll have a look at that also. We'll have a look at your syllabus.
Yeah, and that's what I think. Presently, we are in third semester, and in the next semester we have this lab, robotic programming and simulation lab.
Okay.
That's what I think. The same mail ID what you have forwarded to the present function, because I wanted to know some information from your side so that I can get the quotation for supplying of materials and all these things.
Okay. You see, if you're talking about, I think there's in a lot of syllabus mentioned selection of robo. I think you're mentioning that particular one line from the syllabus. So selection of robo will depend on the things like work envelope, repeatability, reach, width and speed required. All those parameters are there in RoboDK. If you go to the parameter section, they are all available there. But only thing, it cannot automatically select the right robo for your application. That we'll have
Yes, sir,
to.
that's what. Sir. There are some programming is needed for identification of color and shape.
Yeah. That till there it is all. Yes, you can do all that.
That's what. Right, sir.
Okay, so I'll just take
Right.
over the session. Can you see my screen?
Yeah, yes.
Okay. So just for 10 minutes, this is how do you create a custom gripper and a custom robo from scratch from a CAD geometry. That is the intention here. So what I've done is from Google, from one of these free 3D sites, I have imported parts of a gripper. Okay. So I'll quickly show you. I take a blank page and I insert these three robo parts here, gripper parts. Okay. This is from a CAD geometry. Now, in RoboDK, you can create your own mechanisms. For example, let's say I go to model mechanism of a robo. Now, here you have in this two-finger gripper, they have this definition of how this geometry needs to be aligned in which XYZ axis and how it is going to behave. So if you see here in the diagram here, the fingers are going to move along the red axis. Okay. Whereas here they are wrongly aligned. The fingers are 90 degrees off. So even if I go ahead and assemble these as they are, and I say update, what will happen is it creates a mechanism of a gripper like this. But if you operate it, you can see it is totally in the wrong direction here like this. Okay. So this is just realign this entire geometry again. So I take this and okay. Now I go to the base part now. And what I do with this base part is I can rotate this like this by using the arrow keys. and I've rotated this by 90 degrees. Similarly, I do that with each finger also. So here I go. I align this. And even the second finger, I go and align this like this. So now I have the orientation correct for this particular assembly. Now, for this, I also have options like you can change colors. Let's say I want to change color of this. These options are available. These are for better identification. Okay, I've done this. Then I go back to my option of utilities and I say model mechanism for this particular gripper. So I go here. I come here, I say 2-finger gripper and I say create joints between these. I say update and it has created my gripper now. Now here, if I operate this, you can see this, the limits are still very off. I've got the alignment correct, but the limits are very, very off. I need to realign this entire thing. So by using options available here, I set the limits of the gripper opening. And you see this, I'm able to, in this particular fashion, model this particular 2-finger gripper. And once I do this, I've achieved this. What I can do now is I can right click on this and I can say, save this. So I say, save as RoboDK. Custom gripper, and I call it custom 01. I save this. Then I start a here. I take a new station from scratch again, and then I go to RoboDK. Where is it got? Custom gripper. Yeah, this is the gripper which I've saved. But before that, what I'll do is I'll go and pick up a robo. Let's say ABB IRB 120. I pick up from the library here. And then I insert my custom gripper there, which I had already created. Yeah, this gripper has been inserted here. And then I put it on my robo here. So here, if you see, I've got a custom gripper now mounted on this robo. Now, what we had done previously was just the geometry, but if you want to get into the exact degrees of freedom, the kinematic limit settings of this particular gripper, there is an entire list of operations available here. Okay, degrees. So if it's a Fanuc type of a gripper, then what would be the kinematic parameters? All these can be set. Okay, these are all can be, you can set them. Acceleration, speed, joint speed, all these can be set here. And as far as the robo, this is going to behave with this new gripper now here. Even the gripper will open and close here. So in this fashion, you can create a custom gripper. So there are various options available. Then coming to create a full, a robo from scratch. Let's say we want to create a 6-axis industrial robo from scratch. Okay, so for that, let's say I have this. Again, I have 3D parts. Yep. Now, while creating a custom robo, we have to remember one thing, that all robos have this particular definition available. Okay, so if it's a 6-axis industrial robo, it will have these parameters available. What are the distances between the joints, the degrees around the points around which it is supposed to rotate, which joint, etc. And these have to be set properly for your 3D geometry. Okay. So this definition you have to be clear about before trying to build anything. So now let's say I'm trying to build this type of a robo here. So if you see the base, this base looks like this, the first base. So if I import a base, I've imported the base here. But if you compare it to the specification sheet, you can see that the base has to be rightly aligned in the red axis direction here. And here it is not. So I go here. So I go here and I can totally realign this entire object to the direction I want here. Okay. So I got this object aligned in the correct direction. So this is my base. Then what I do is I pick up the second part. Okay, again, the second part is totally wrongly aligned. So I double click on this and I move this. Yeah. Okay, this is still in the wrong direction. This has to become like this. So what I've done is I've placed my first two objects correctly. Then again, I can go to utilities. I can say modern mechanism of robo. And here I can go and I can choose 6-axis industrial robo. Okay, this is the configuration diagram here. And I say base, create a link to link 1. And I say update. The moment I do that, it has created my mechanism here. If I operate this, you can see I've got my first joint correctly defined here. Okay. Now I will move on to the second joint. So I put in the second joint here. This is also again wrongly aligned. I move this again. I place it like this. Okay. Once this is placed, then I need to refer my my mechanism here. Now, if you follow this definition properly, the distance of A2 with respect to the base, the reference frame, etc., it is not difficult. Very easily you can find out the centers of rotation and the exact placements of all of these. Okay, this I just done for demo sake. So one by one, you start inserting every object like this and start creating your own custom robo. And I've already done that. So here, so if you see here, this robo on the right, this is a custom robo created. And I've attached a gripper. So I can also insert a ready-made gripper if I want. If I go to the library and I say robotic gripper here. Yeah. So to a custom gripper, I've attached a robotic library gripper, and they are going to behave themselves here like this. Again, for this particular robo, the entire for the inverse kinematic section is available here. Yeah. You can choose the type of solver you want, whether it's Fanuc based, ABB. In the industry, these are the typical solvers in the background for the inverse kinematics. So these are all available for modification. Also, later on, if you want to post-process this particular file for a particular brand of robo, you can even post-process this depending on what type of a robo you're targeting at. So in this fashion, you can create custom grippers as well as robots, 2, 3, 4, 5, 6 axis. You can create these mechanisms here. This is the list here. Okay, sir. I think we'll wrap up the session here. If you have any questions, please feel free to ask now.
Again, here also the animations, what we are going to conduct, no, as per the program and as per the color identification of the each object, if the program needs to change for different kind of a softwares or for a different kind of the
Different brand of robots.
different bond of exactly different bond of
Okay, it may need to change. Because see what happens is for a particular robo, there is always something known as singularity issues. Okay, I'll give you an example. One.
and even the synchronization also, does it place a vertical parameter?
See, automatic synchronization. See, for example, if I move this robo, this is joint to joint, but the moment I go to shift it in one particular linear line, one robo may have a limitation on reach compared to another robo.
Yeah, yeah.
You get me? So
Yeah, yes,
you'll
sir.
have.
And even kinematics also will change, sir.
Yes, yes, sir. Everything will change. So though the interface is same, what you're getting on the right hand side, the same program may not work for a different type of application.
Yeah.
The interface will be same. The
Yeah.
reachability may not be there. You know, the envelope may be something different. So because there are hundreds of robots available here, so each one has a different, what do you say, inverse kinematics as well as payloads and IK settings.
Yes.
The program has to change. You can't just go and say replace a robo using the same program. No.
At least if you change one parameter, then the programming has to be completely rewritten.
Yes, yes, yes. See,
Which
there
is
is
the
an
best?
option here, replace robo. Okay.
Mhm.
For example, this is my custom robo. See, though it has a command, I'll be very frank. It says, where is it gone? Replace robo. And I want to replace it with the RV120. It has replaced. Okay. Automatically. But then there might be errors in the program. It may not reach certain points.
Is there any parameter, is there any some kind of a conditions or boundary conditions where this kind of a robot is best suitable for so operations?
No,
Especially
sir.
for
That
simulation kind of a
that
thing.
will be more of a
Because
study.
exactly, and even everything, even the programming language. Which is the programming language, sir? Generally, we are going to use it for simulation kind of thing.
See, what happens is in RoboDK, do we have a program? 1 minute. See, what happens is when you right click and say generate program, you can actually generate targeted at a particular brand of a robo or post processor. So that program keeps changing depending on your selection. Do I have an example? 1 minute. Let's check.
Why I'm asking, because I'm new into it, sir. That's what I need to know. I'm very curious about that. And since we have a laboratory setup in the next semester, and
Okay.
I'm searching for so many customers to supply the quotation, all these things.
Okay, now let's say I've taken 2 targets and I say create program. In this program, see, there's it has found one singularity here. So I create this, I remove the singularity and I run the program. Okay. Now this is there. Then I can say here generate robo program. Okay. Before that, one minute. This is correct. Okay. Generate Program folder desktop. Select folder. It has created this program here. Okay. This program is also editable. Not only that, but you can also target this at a particular post processor. You can select post processor. And if you regenerate this, see, right now we've taken maybe a custom robo, but you want it in the language of, let's say, another robo. Let's say this is ABB, right? Let's say KUKA. And then generate the program again. See, this entire thing has changed.
Yes. Yeah, earlier it was 27, now it is more than 55, double than.
Yeah. So you can choose the post processor for what type of output you want. Obviously, it has things like Python support, this, that, that is there. And in the
most of
beginning,
the programming,
pardon?
Most of the program runs with the DOS based model, sir.
No, this is opened up in a DOS based mode. But this program can be then either post processed for a target robo controller or something like that. And like I told you, each of these industry robos have their own programming language, which is very typical to them.
Yes,
so
that is the reason I think they are in the market.
Yes,
otherwise
they will not open up their.
It's the secret of business.
Yes, like I told you, see, in the beginning, I had shown you this. For example, KUKA has a KRL language, proprietary to KUKA only. Okay, and the software uses KUKA Sim. If you go to Fanuc, it has its own proprietary language, Karel. You go to Mitsubishi, Melfa Basic 4.5. Now, these are all proprietary belonging to these companies only. They will not open up this. But RoboDK can target any of these as post processors and generate the code for them.
Only for limited or for all kind of industrial applications?
So I think all kind, because it's a huge list. Because this software is primarily for the industrial purpose. In India, they're like little bit, we picked up the initiative, so it's come to educational in a little strong way. We are promoting it heavily. But worldwide, the application is more industrial based.
Yes. That's what when they ask anybody, they say that we are more towards industry oriented rather than academia.
Yeah.
That is one of the other side of a scenario where to implement the RA in at the institution level, they're facing a bit difficulty.
Correct, sir.
Yes, sir. It is wonderful information. What is that? As for my concept, it is too good. Right, I think we'll be in touch with you people because anyway, I have your information. Further, I think I'll communicate you.
If you have anything else, let us know. You can mail us. You want particular literature. And RoboDK has got a huge online forum, all type of data available. Even later on.
Yes,
Because the end of the day, we all are doctorate levels, you all do more playing around than what we do.
Sir, here it needs more of the practical thing rather than any doctorate or any kind of thing.
Yes. The more you use it, the more you want to get into the complications.
Yes, exactly, sir. Okay, sir. I think I'll get back to you, sir.
Okay, sir. Thank you so much.
Thank you,
Hello, sir.
Yes, sir.
Hello. I'm Mahesh from JSSAT Bangalore, sir.
Okay.
Regarding this software, do you have any instructor manual so that we can practice or work on this demo or trial version?
Yes. There's an entire online help available, sir. It is in a help type of this thing with linked videos also.
Okay.
So yes, the help is tremendous. That you don't have to worry about.
Okay. So that's what you have demonstrated here on screen. We have come across various custom built robo also. So for that, if you come across with any instructor manual like step by step, you go to exploring the software towards in depth.
Yes, there are.
There are available. Okay.
Yes.
Yeah.
Only thing
Thank
is
you.
that, sir, you need to purchase the software.
Okay. Yeah. Fine. Understand. Yeah. Anyhow, thank you, sir. Thank you.
Thank you. Thank you so much.
Thank you, sir.